we're going to turn it over. We're also going to England, and we're going to be joined by Oliver and Lawrence, who are going to talk to us about physics and musical farce, a perfect experiment, a case study in the success of promoting learning of advanced concepts in physics through the medium of musical theater. So from quantum mechanics to another story about quantum mechanics. Gentlemen, take it away.
Good. Hello from Southampton, where it's raining and it's night time now. Yeah, we'd like to talk about the musical theatre productions that Ollie and I have put on over the last 15 years or so, to try and get our children in our schools interested in both musical theatre and in physics. I'm going to be reading from a script just below the camera, so you'll see quite a bit of my eyes going down, because if I don't, I'll just talk for too long. So I'm sorry about that. Right, so let's get started. So between 2005 and 2018, we produced 3 musical theatre productions, written and produced. And the aim of these was to promote the understanding of concepts in the historical and theoretical development of physics, as well as giving all those involved in understanding that creativity and imagination are behind all intellectual and artistic endeavours. And we're currently working on a 4th musical that should be shown in summer 2020. So let's have a closer look at the musicals themselves. The first one was Einstein the musical, and we wrote this initially for the centenary year of Einstein's famous 1905 miraculous year. And this was a show based on the reflections of one of the characters, who was the older Einstein, and he was reflecting on the work he carried out in his youth, and it included staged and sung analogies for all his major theoretical interests. This production was really a sort of talk on Einstein's work set to music. It wasn't a play as such, but each of his landmark papers was explained in musical and, I hope, comic fashion. We followed this up with the more ambitious That Certain Uncertainty, which is, it says there's a musical comedy of love, loss and quantum physics. And with this, we had 2 entrances to the stage, which throughout the play evoked the 2-slit thought experiment. And a group of 3 physicists on their way to Copenhagen excitedly discussed the experiment, so there was a very clear link to what the audience was seeing and the physics we were hopefully trying to get across. A couple of years ago, we put on Welcome to Gedanken. This was another farce, and this explored the null result of the so-called Michelson-Morley experiment and took in a number of other ideas from physics, philosophy and psychology. This play ended with the publication of Einstein's statement of the non-existence of Gedanken experiments in the play had been misinterpreted as experiments taking place in Gedanken. And lastly, the play under construction at the moment, there we are working on it in my kitchen, No Time Like the Present. This explores different models of time, drawing on thermodynamics, relativity, and quantum mechanics. So what are we trying to get out of this for the students? We both teach in 11 to 18 schools, and we're keen to give them an experience of music and of physics. The first principle that we want to get across is creativity. Now, I think it's an exciting challenge for any teacher, but perhaps particularly science teachers, to ensure that her or his lessons have a sense of creativity running through them as one of the many threads that lead to an understanding of the world around us. But as physicists, we must remember that perhaps our understanding of the word creativity is different from that of our students. I think there's occasionally a temptation to equate creativity in science lessons just with sort of fun, rather than as a complementary way of looking at an idea, which requires as much thought and respect as the quantitative mathematical approach usually taken. I wouldn't want to think of creativity as a sort of lightweight filler in lessons. It should be absolutely running through the vein of the lesson. Now, the participants in our musicals often have no experience of performing, but develop an understanding or the rigour of the performance and can see how creativity on stage is constrained. You don't just invent the words as you go along in a play, you interpret them for the audience in much the same way as creativity is constrained in physics lessons, where you use an old equation, but you should use it creatively and imaginatively, even at quite a low level. Now, the performers and the audience engage creatively with the musicals on two levels. First of all, they see the piece of work as a creative work involving, as it says there, actors, designers, singers, musicians, and so on and so forth. But also, on the secondary and perhaps more important level, the characters in the plays themselves are shown as creative individuals as they discuss, debate, and argue about their ideas. And in this way, we hope to show that the creative endeavour is vital, both in physics and in the expressive arts. We're giving equal respect and prominence to the complementary perspectives. Next thing which we're concerned about is metaphor. Physics is a mathematical subject, and so any non-mathematical explanation of its principles relies heavily on metaphor. And these metaphors are so deeply ingrained, you don't even notice them. For example, light is a wave motion. That's a metaphor. The metaphor of the field, time flowing, and even such obvious concepts as sunset and sunrise are metaphorical. And the scripts for our musicals take metaphor in physics absolutely head on. For example, in That Uncertainty, which is about the uncertainty principle, there are two groups of guests at a local hotel, and they must never meet. One group is three physicists. You can see one of them there holding up the famous two slits. And as the farce unfolds, the guests often enter and emerge from two doors on the set. A metaphor, of course, was two-slit experiment. In the final act, the two groups fully meet after a mysterious mutual recognition of the dowager and the eldest physicist, who split apart much earlier in their lives. This is a nice metaphor for entanglement. And here is a very brief clip of that moment presented in song. I hope you can hear that. We can't, because obviously that would mess up things. Now, our first play, Einstein the Musical, was rather more didactic in nature. But for example, the song Little Leela Lightbeam, involving a cross-dressing Leela surrounded by sailors singing that she didn't know if she wants to be a pebble on the beach or a wave upon the sea, was a very obvious metaphor for wave-particle duality. And lastly, Welcome to Gedanken uses the idea of an unobserved Ruritanian country called Gedanken, which explains in the play the tensions in the early years of the 20th century. This is made explicit as a metaphor for the unobserved ether, explaining the motion of light. And when we're on explanation, we might as well come to the use of explanation in our plays, because of course, as we're trying to describe physics, how we explain things is absolutely central to the narrative. As I've said, Einstein the Musical just took a tour through the papers Einstein published in his miraculous year. And in Einstein, a narrator took charge, that's her, whilst the older Einstein sat at the edge of the stage, that's him. And he commented on his youthful self, that's him, who performed the songs and described the physics. And the audience were in absolutely no doubt that they were being instructed about physics, and the feeling which was enhanced by the fact that they had to sit through a talk on physics before the show. Now, examples of the way we use theatre to explain physics include some lab coat-dressed scientists holding a cage representing the ether, as is shown in this very short couple of clips.
Now, you can't see the ether, but it was believed to be there because waves need something to travel through. Now, let's imagine the Earth in the middle of this bit of the universe. Ah, Colin, perfect. We all know that the Earth is going around the sun, and that the sun is in a galaxy which is spinning. So, if the ether is the stuff of the universe, and if the Earth is going around the sun, then the Earth is actually going through the ether.
I'm getting excited now.
I think you can hear there that the audience was enjoying it, weirdly.
I enjoyed it.
I don't know why it was so funny, but it was. And the second one is an astronaut who was worried about relativity, and here he is.
The faster I move, the slower time goes, but where the time goes, nobody knows. The quicker I go, the more massive I get, but I haven't burst out of my spacesuit just yet. I don't understand relativity. It's all very weird for an astronaut like me.
And now, as I said, Einstein was very didactic. That certain uncertainty had a much stronger narrative arc, but still relied on a narrator, in this case, the historical figure of George Gamow, to help the audience through the physics they were watching unfold. And we thought this was necessary because it was quite complex material in this play. But Gamow's explanations were supported by the three physicists. There they are in the play, who explain much of the physics in song. Welcome to Gedanken, the third play in the series, didn't use a narrator at all, but once again, the ever-present scientists helped the audience understand what was going on through a number of viewpoints and indeed a number of songs. And the bottom left image is from that thing. So my phone's just gone off, that's why I'm just turning it off. Now, as we grew more confident in musical theatre and using it to illustrate physics, we put more and more explanatory material into the songs themselves. For example, in That Certain Uncertainty, it opens with a song which explains the clause in nature's laws. And here's a very short clip.
Telephones are just too smart and everybody wants them. Just so they can talk about the physics of the quantum. There's a clause in nature's laws that no physicist ignores, which is simply that certain, plainly that certain, simply that certain.
And you can see we had quite a big cast for that. Later in the show, the song Everything is Made Up of Atoms gives a very quick rundown of developments for atomic theory from Democritus to Bohr. And here's just a very quick clip of that one.
Everything is made up of atoms, and atoms cannot be destroyed. In reality, all the world we see is simply atoms moving through the empty void. Everything is made up of atoms. Atoms are the smallest things there are.
And lastly, for the moment from the play, the scientists later on consider wave-particle duality, again using song to express their ideas.
Quantum physics seems to show a magical wonderland. But in 1927, with the little we know, it's hard to understand how an electron pull us starts like a penny to be into places at once. Perhaps you'll agree, or a physicist might be, that's the central mystery. Quantum physics seems to show a brand new mode of thought.
Okay, now in addition to all that, we're quite careful about the programmes, because the programmes always contain the scientific background to the ideas we're trying to get across. The audience have a really good educative experience as well as hopefully enjoying themselves, which we think they do. Now, the student learners are engaged, we hope, and this is very basic. I think we all know that if the teacher is engaged in the subject, the students are more likely to become engaged in the subject. So to this end, when we do these plays, we try and get as many teachers as possible involved in it. In that certain uncertainty, out of the physics department of 6 members, we have 1 member playing the guitar, bass and cello in the band, 1 in the chorus, 1 in a major role, 1 did the choreography, and so on. Now, another thing we're careful about is that in the UK, not many girls go on to study physics in the later school years or at university. And so in our plays, we make absolutely sure that there are equal number of girls and boys and major characters to really give girls the limelight while singing and talking about physics. And of course, we've got to engage the audience. And to do that, you've just got to make it entertaining, we hope. Because I think it's a mark of a successful sort of happy musical if the audience leave the auditorium wishing they'd been in the cast because it looks so much fun. This is absolutely our aim, because when the audience is engaged with the story in this way and the characters, they also engage in the physics and they're more likely to come away having learned a bit more about the physics. And indeed, the applause at the end of our plays suggests that this has worked. Okay, now in the UK, a lot of teaching and learning is becoming increasingly driven by examinations. And as a subject teacher, as we are, it's easy to forget that if you've got a class of 15-year-olds and you teach them, say, physics for 50 minutes in the morning, they then go off to do another subject for the next 50 minutes, then another one, then another one. And so it's really difficult for the boys and girls, never mind the teacher, to really dig deeply into the subject. And so taking part in musicals like this gives them a bit of space to actually investigate what's going on in the subject, and we believe that this can diffuse back into their lessons. Now, we spend a lot of time looking at the quality of what we do, so we have a lot of rehearsals, make sure these are enjoyed as much as the shows, and the children know it really is a group effort. They can make their own comments about it, they can suggest things for the choreography and so on and so forth. And we really support them, and by expecting them to do well, we get very good performances out of the students, which perhaps you've just seen a tiny bit of. And lastly, in order to make them feel serious about it, we stage the plays in high quality professional venues. So, for example, this is the Theatre Hall in Winchester in England. This is our Nuffield Theatre in Southampton. And we've also done it in the Winchester Planetarium to get the scientific audience across. Now I'm going to hand over to Ollie, who's going to talk about the musicality of the pieces.
So, hi everyone. Lawrence basically handles the physics, and I tend to look after the music a little bit more in the composition and arrangement and all that kind of stuff. And so all 3 of the musicals produced have contained a real mixture of very talented, trained musicians, but alongside complete musical novices. And the compositional and subsequent arrangement and staging process reflects this throughout. As a result, the musical experience is kind of tailored to enhance and enrich all those taking part, from the most able to the beginner. And that's kind of the pedagogic principle, that they should all be able to increase their musicality and take part. This is achieved in the following ways. First of all, orchestral and band parts are written specifically for the musicians accompanying the singers, so for the individuals. And the ability of the performers was considered. And evidence of this can be seen in unorthodox instrumentation and doubling of parts. So, for example, in Einstein the Musical, on the screen there, you can see that there's a double violin doubling French horn, and a piano with a ukulele, and a violin with a trombone. This wouldn't be regular orchestrations, but these are for the individuals. And on the left-hand side and the right-hand side, that's the same song, but with different instrumentation as the song progresses, as they change their instruments. And alongside that, we're able to stretch musical moments for the players. And so, again, an example, it's hard being rich from that certain uncertainty. There's some really quite challenging clarinet parts in this. And here's a little clip that kind of puts that into perspective. as you can see, they're being pushed there to the limits of their abilities, and that's got to be a good thing. But as we said, we're keen to get as many pupils involved as possible, and so this can be seen in the large number of ukulele players in the chorus, but also in the number of instrumental musicians in the band. So in Einstein the Musical, we had a large band, and the players, we gave them as much exposure as we could through the inclusion of overtures to both the acts. And here's a clip of them in action. And sometimes it's hard to remember, but some of those children are 12, 13 years old, so and haven't performed on a stage in that way before. So it's really really good thing to be able to do. Thinking about the singers more specifically, the same thing is true. Vocal parts were written to stretch all of the performers. Now they're cast members who had never performed on stage and certainly never sung in public. And so I had to consider the vocal ranges to make sure that they're enhanced their lack of experience, and the keys were chosen so that tunes would sit comfortably and increase confidence. And for those who had performed before, more complex harmony parts were included with greater range. So in that certain uncertainty again, the character Freddie had much more vocal experience than the rest of the cast. And this is why his parts are much more complex. And here's a clip of the song, There's a Certain Uncertainty, where he duets in harmony and he's being a little bit vocally more adventurous.
Ready, I'm ready, take my hand in hand, we'll walk along the path, recalling all the joys of a love-lifted path. You from me, I found you from now on, sing my blues, we're certainly in love.
Chorus parts as well developed to engage as many young students as possible. And by young students, we have two choruses, one for pupils aged 14 to 18 and another of pupils aged 11 to 13. And the younger pupils are generally given the big numbers to sing, often appearing at the start or the end of acts. They tend to sing the more catchy numbers. And in the first clip from Einstein that you're about to see, you'll see some young pupils with silver hair that they're representing photons. And you can see that the whole cast and them in particular are really enjoying their singing, which is wonderful to see. And the large chorus singing about physics was something that we definitely wanted to continue. And in the next musical, That Certain Uncertainty, we had a similarly large chorus. Here they are in action on a train on the way to Copenhagen, where they're investigating the experiments that are happening there.
I want to be in Copenhagen. I want to be at Copenhagen. I'll sing for me in Copenhagen when I meet all the physicists that are there. I want to go to science.
So there's great educational benefits musically as well as in the world of physics. And that's really where the partnership has worked so well, that we're both able to push the musicians and the physicists in the same direction. I'm going to hand back to Lawrence now, who's just going to provide a little conclusion.
So, yeah, thank you. Over the last 15 years, we found that doing this and developing these musicals, for us, has been one of the highlights of our work. And it's undoubtedly true that the students remember it. They write to me and they tell me, some of them are almost 30 now, and they're still in contact saying how much they enjoyed it. And some of them have gone on to be musicians, others physicists, and all kinds of things. And I'd just like to end by paying tribute to those incredibly talented young people that we've been lucky enough to work with. And we're going to end up with a bit of musical brainwashing in the finale of That Certain Uncertainty, where we got about 40 children to sing I Love Physics. Here it is.
You love physics, we all love physics, so let your physics go down. I love physics, you love physics, we all love physics, so let your physics go down. I love physics, you love physics, we all love physics, so let your physics go down. I love physics, you love physics, we all love physics, so let your physics go down. Don't be miserable, let's get physical now.
Thank you very much for listening and watching.
Wow, gentlemen, that I'm going to give you a standing ovation. Let me stand up. That was great. That was awesome. We're so lucky to have you guys. This is great. Talk about creativity. We have lots of comments for you guys. Everybody thinks that this is super impressive. I think one question on everybody's mind is, number one, how do you carve out the time in your day to do this? And number two, how did you guys meet each other?
Well, we met because we worked in the same school. We don't work in the same school anymore. I'm now in Devon, which is in the west, and Lawrence is in Southampton, which is in the south of England. But we did work together for 10 years. And we met through a mutual love of exploration of all things, not just physics and music, but literature and all sorts of other things as well. And just kind of struck up a relationship in the first project that wanted us to push that further and explore the music a little bit more and see how far we could take it, really.
Well, I think you've taken it pretty far. Yeah, definitely. I would agree to that. That's amazing. You guys do some great work. Does anybody have an undying question? If you want to type it into the chat box. One question that actually did pop up is, how do you get your senior educational leaders on board with something like this?
That's quite hard.
Okay.
And I have to battle with that quite a bit. And also in any school, of course, these are big productions now. The school has its own big productions. For example, this year the school's putting on West Side Story, and that's a big production. And so to fit in my new musical, when you're comparing it to West Side Story, you have to be a bit hard-nosed about it sometimes, which is tricky. It was easier when Ollie was working in the music department, but now, although the music department are very supportive, they're just really busy on their own thing. So it is hard.